So we're in Genesis chapter 1, verse 24. God said, "Let the earth bring forth the living creature after his kind, cattle and creeping thing and beast of the earth after his kind," and it was so. And God made the beast of the earth after his kind, the cattle after their kind, and everything that creepeth upon the earth after his kind. And God saw that it was good. Now, a test question. This is a review in a sense. Why is it that the animals always produce after their own kind? The scripture says so, yes, but why is it operationally so? How are they defined? Is it, what? Very good. Digital, that's the word, exactly. The DNA is a 3 out of 4 digital code. And the implications of it being a digital code is still unappreciated by many biologists, but that makes it definitive. It's digital, not analog. And that's implied in here. We could talk a lot about the animals, but one of the questions that we need to raise is why, after 120 years or more of searching, have there been no missing links? You know, when Darwin proposed his Origin of the Species, there's a lot of optimism that they would ultimately find all the little missing links. They found zero, none of them. And that's because they're digitally defined. Now, there are evidences of design in each species of animal. But in the interest of getting through this session in a reasonable time, I'm just going to take one animal as an example, okay? A common animal, one that you've all seen, the giraffe. How many have seen a giraffe? These are interesting creatures. I'm going to use this guy, as just an exemplar of what you'll find if you look carefully in every animal species. You'll find something unique that required anticipatory design. Now, the giraffe grows to be about 19 feet tall. It's the tallest animal that's currently around. Weighs about 2,500 pounds. He can run about 36 miles an hour. He eats about 201 pounds of food per day. He does that spending between 16 and 20 hours eating per day. When does he sleep? He sleeps about 20 minutes a day. That's your giraffe. Interesting character. This guy's an interesting character. He can go without water for months at a time, interestingly enough. And of course, in some of his habitats, he has to. But there's some strange things about a giraffe. Being so tall, it takes quite a bit of blood pressure to get the blood to his brain. The giraffe's aorta has about 220 millimeters of mercury pressure when he's normally standing. This pressure would be dangerously high in a human. But in a giraffe, it's necessary to get the blood up his long neck to his brain. And to accomplish this, he has a heart that's about 2.5 feet long, a huge thing. But he's got a problem. When he bends down to drink water, he's got two problems at least. One is that's when he's vulnerable. That's when you would expect a lion to leap out of the underbrush that's been waiting for the opportunity to take him. The other problem he has is that the pressure would normally be enough to burst the blood vessels in his brain, because it's designed to be 18 feet in the air. It's now at water level, and he would have what a diver would call embolism, right? Well, so what's the answer here? Well, it turns out that there are valves in the artery going up to his head that adjust. When he goes down, those valves close. The blood between the last valve and the brain goes into a sponge. It's diverted around the brain into a sponge-like group of vessels underneath the brain that's called the retin, whatever that means. It's an organ specifically designed to absorb that pressure and to act as a reservoir. As he raises when he's down there drinking, if he was to suddenly raise his head, he'd have just the opposite problem. He'd have no blood in his brain, and he'd have a dizzy spell, he'd pass out, whatever. But because this sponge-like reservoir is there to feed oxygenated blood to his brain, as he comes up, the veins coming down from his head also have valves that are designed to equalize the pressure. So as his head goes from 18 feet in the ground into the water, it's sealed off. But as he comes up, there's a reservoir underneath the brain in the sponge-like organ, And but the point is, it's all been designed in anticipation of his lifestyle. Now, what makes this particularly useful as an example, I want you to imagine how this evolved. Because the deficiencies in his design are fatal. And you got to remember one thing about evolution. Dead animals don't evolve. Okay? So if he has a blood hemorrhage and dies, there's no way to pass on that experience, however you want to fancifully imagine it, to his offspring. Whether it's because he brought his head down, had an embolism, or because not somehow having that equalized, maybe getting his head up, he would pass out when the lion's about to eat him. So, and if the lion eats him, of course, that leaves a very, very difficult fossil for. Anyway, you get the idea. Okay. So, what's interesting is you can find hundreds of examples where there is an essential design element, either in their skeleton or their circulation system or whatever, that is essential for their survival. And trying to conjure up out of one's imagination an evolutionary hypothesis of how it got there is an errand, it's a fool's errand. Because the defects, especially in their interim phases, are deficient, and he dies. And the survival of the fittest motif makes sure that the interim stages are gone. Do you follow me? So, and anyway, the vein. So you got special design of the heart, special design of the arteries going up, special design of this special sponge-like organism underneath the brain, and a special design of the veins coming down. Very, very skillful design. And what's the greatest insult you can give the designer? To assume it wasn't necessary, it all happened randomly, right?